Hello children, consider these two numbers 23 and 20. Now we are going to divide these two numbers by 5. We are just going to revise whatever we have done since our earlier classes, division, right? It would be very easy for you, but just that we have to note some facts from here. So first of all, dividing 23 by 5. Divide 23 by 5. 23 is called the dividend and 5 is called the divisor. So 4 times 5 is 20. So we have 3 as the remainder. So can I write this division fact like this? 23 is 5 multiplied by 4 plus 3. So 23 can be expressed this way. That is, dividend is equal to divisor into quotient plus remainder, right? Now just divide 20. 5 4 times is 20, it exactly divides. 5 exactly divides 20, 0 is the remainder. And this division fact can be written this way, 5 multiplied by 4 plus 0. So here remainder is 3 and here the remainder is 0, right? Now what is the difference between the two? Just that from the first one I can conclude that 4 and 5 are not factors of 23, right? They are not the factors of 23. Why? Because we have a remainder while dividing, isn't it? And similarly, since we have no remainder, the division has happened without any remainder, you can safely conclude that 5 and 4 are factors of 20 and 20 is a multiple of 4 and 5. 20 is multiple of 4 and 5, right? So now our purpose, the aim of our video is to extend this division to polynomial long division. So when you are given two polynomial expressions, you can still divide, just that you can add them, you can subtract them, you have learnt it. You can multiply polynomials. So we can also divide polynomials the same way, just like how we deal with numbers. So dividing one polynomial by another simple polynomial. And let me take this very simple example. Divide 2x squared plus 9x. Let's divide the whole thing by a monomial x. Just for simplicity, we are starting this, right? So since I can divide this term by term, 2x squared divided by x plus 9x divided by x. Now x is common to both the numerator and denominator in both the terms, isn't it? So this can be safely divided and written as x squared, x remains, and here both x gets cancelled to 2x plus 9, right? So this is your quotient, isn't it? This is your quotient here, and there is no remainder, so remainder is 0. So of course, there's a very easy way of doing this. You just looking at this, you know that x is common to both. So using the reverse of the distributive property, you can write it in terms of x divided by 2x plus 9. The whole thing divided by x. The x is common in both numerators and denominators. You take it out and you get the same quotient, 2x plus 9, isn't it? Now the division fact. Can we write the division fact the same way we did with numbers? Of course we can. How did we do in numbers? We wrote dividend is equal to divisor multiplied by quotient, right, plus the remainder. Same way, what is the dividend here? 2x squared plus 9x is equal to the divisor x, the quotient 2x plus 9, I'll write this within brackets, isn't it? Plus there is no remainder, so 0. So just like I concluded for numbers, I can conclude here that x and 2x plus 9 are factors of my initial polynomial which I started with, are factors of 2x squared plus 9x, right? So this was very simple. We divided it this way. Now consider some other polynomial. this one 4x squared plus x plus 1, the whole thing divided by x. So if I do it term by term, where will it take me? Just like I did the previous one, I do it term by term. 4x squared by x plus x by x. But look at the last term, 1 by x. 1 by x cannot be divided. There is no x in the numerator. It is 1. So we cannot perform a division. So 1 will be the remainder of this whole division. Right? Now this is what we are going to learn now in this video. How to do a long division polynomial, how to divide any polynomial by a non-zero polynomial. So let me take this example. I have a polynomial here, I call it a polynomial in x, which is 4x squared plus x minus 2. And let me have another polynomial, this is my divisor. I have to divide 4x squared plus x minus 2 by x plus 2. So just like our numerical division. Now let us start doing this. 4x squared plus x minus 2 has to be divided by x plus 2, right? So you notice that x plus 2 is a non-zero polynomial. What do we mean by a non-zero polynomial? It is not a number. Any constant. Suppose if you have a p of x is equal to 5, you call it a zero polynomial, right? There is no variable in this. But this is a non-zero polynomial of degree 1, right? This is of degree 1. So x plus 2. Fine. So let's go about this. Let us consider the first term, 4x squared. Now let's ignore all the other terms and see the first term. What is a multiple of x which multiplies the first term exactly? Now that is my question is, what do I multiply x into what would give me 4x squared? So this is how I start. So x into 4 and another x, right? This is going to give me 4x squared. Fine. So let me write there into 4x. So let me write it above the x term, because x, and of course we are now going to multiply and find two terms. 4x into x, 4x squared, 4x into 2, 4x into 2, 8x, right? And just like we did in our numerical division, now we have to subtract the whole thing, right? And that is minus 4x squared and minus 8x. So instead of putting a common sign, let me write minus here and minus here. So, and now our subtraction. What is x minus 8x? X minus 8x is a negative of 7x. Of course, these two is 0, right? I do not have to mention it, but 0 minus 7x. Now, let us consider 7x. What will I multiply x with to get minus 7x? Obviously, it's minus 7. Now, minus 7 into x, minus 7x. Minus 7 into 2 would give me minus 7 2's 14, right? But I have forgotten to bring this term down, minus 2. Normally, this is what we do in our numerical division also, right? Suppose I am dividing by 363 by 7, 7 5's 35. Apart from 6 minus 5, 1, I bring this 3 down. Similarly, I'll have to bring this 2 down here. Fine. So, I have scribbled here. Okay. Now, subtracting. Subtracting means again, the whole thing has to be subtracted, isn't it? So instead of putting a whole subtraction sign, I would change these signs to plus 7x plus 14. So as usual, my first term minus 7x plus 7x becomes 0, and plus 14 minus 2 is plus 12. Now I cannot divide further. You notice that this is a zero polynomial. The degree of this polynomial is 0, which is lesser than the degree of the quotient, the divisor. What is the degree of the divisor? It is 1, isn't it? Degree of the divisor is 1, the degree of this is 0. Now this cannot be further divided. Now, shall I write the same division statement? What was the division statement? Dividend is equal to divisor multiplied by quotient plus remainder. So, what is my dividend here? I started dividing p of x, isn't it? 4x squared plus x minus 2. This is equal to, what is my divisor? Divisor is g of x, x plus 2. X plus 2 multiplied by quotient 4x minus 7, the whole thing, plus the remainder, which is 12. Fine. So, what have I got? I started with p of x. This is equal to x plus 2 is what? X plus 2 was g of x. So, this is some quotient. So, let me call it q of x plus the remainder. So, the remainder can be written as r of x. Here it is not a polynomial, but what if we divide a higher degree? What if our divisor is of higher degree more than 1? So, our remainder also may be a polynomial in x, so r of x. So, this is how we go about our division. So, what do we conclude here after this division? The remainder is obtained by dividing 4x squared plus x minus 2 by x plus 2. The remainder which is obtained here is 12. So, in general, if you are given any two polynomials p of x and g of x, for any two polynomials, you can divide. You can always divide these two polynomials, but there are some conditions for this division, which are obvious, but let me state it. The degree of p of x. The degree of p of x should be greater than or equal to the degree of g of x. In our case, see, the degree of p of x was 2, the degree of g of x was 1, right? So, this is one condition. And what about the other very important condition which holds good in numbers also? G of x should not be equal to 0, because you cannot divide any number by 0. Same way, you cannot divide any polynomial by 0. So, when you are given two polynomials p of x and g of x, you can always divide them provided these two conditions, and after dividing you can find any two polynomials q of x. You can find these two polynomials q of x and r of x such that they satisfy p of x is equal to g of x into q of x plus the remainder, right? So, in our case, the remainder was 0, isn't it? So, here also we have some conditions. Either remainder would be 0, write these conditions down. You get a remainder in such a way that either remainder would be equal to a 0 polynomial. By 0, I mean it would be a 0 polynomial, or the degree of the remainder. The degree of remainder would be lesser than, the degree of the remainder would be lesser than the degree of the quotient. Degree of the divisor. The division stops here, just like your numerical division. When the degree of the remainder is lesser than the degree of divisor, your numerical division stops. Of course, there are no degrees there, it is numbers. So, when you divide, where does your division stop? I again divide the same number, 24, and show you. Where does your division stop? Suppose this is 4, the remainder is less than 5. What if I had 26 here and I got a 6 here? My division is not going to stop here. Now I have to look for one more multiple of 5. 5 5s are 25, isn't it? So, these two are the important conditions for the remainder. One is r of x, either it's a 0 polynomial or degree of the remainder is less than the degree of the divisor g of x. Fine. So this is our polynomial division. I hope you understand. In my next video, let us see a hint for the remainder theorem. We'll do one more division and look into the remainder theorem a little. Of course, the proof I'll do it later. But this division, long division, gives you a hint to the remainder theorem. So thank you. I hope you understood.